morning. Again, we want to continue our discussion on the subject physics. So far, we have taught in the previous classes about the physical optics. We have completed up to diffraction. That is called the least distance, and also magnifying power of various, our human eye, microscope, telescope, and even for grating. Today we can pass on to the last topic of wave optics, polarization. The polarization, we have to keep your mind. We know the ordinary light. Ordinary light have transverse in nature. Everyone aware of it. Transverse in nature means the perpendicular vibration of the particle. The perpendicular vibration of the particle for this plane, or this is also perpendicular vibration, this is also perpendicular. So, this perpendicular vibration is not restricted. This perpendicular vibration may be any plane. That is called ordinary light. If these vibrations are perpendicular vibrations restricted to single plane, perpendicular vibrations are restricted to single plane, then the motion is called polarized light. So, unpolarized light also perpendicular vibration, polarized light also perpendicular vibration. You should not confuse yourself. Both are perpendicular vibration. So, here the vibrations are restricted to single plane. In ordinary light, vibrations are not restricted. At any plane, it is perpendicular vibration. Therefore, so this is the indication of polarized light. So, this is perpendicular for this plane. This plane alone, it may be perpendicular. So, it is the vibration. So, some definition also you have to understand about the polarization. So, here unpolarized light may be converted into polarized light. Unpolarized light can be converted into polarized light by using a crystal. If an ordinary light passes through a crystal, the crystal restricts the vibration. Any object which is useful to produce polarized light is called polarizer. Any instrument used to check whether the light is polarized or not, that is the instrument, is called analyzer. And what is plane of vibration? It is the plane in which particles are vibrating. What is plane of polarization? The plane which is perpendicular to plane of vibration is called plane of polarization. Or it is the plane where no vibration of particle is expected. Like that you have to remember the definitions and make sure of it. And also you want to discuss about the polarization. The polarization by reflection. The polarization by reflection actually given by the scientist Malus. But in our book, in our state board book, directly they converted into Brewster's law. Then what is called polarization by reflection? I take a reflecting plane, any time normal. If light rays are incident for a particular angle of incidence, the particular angle of incidence is called angle of polarization. Not for all the angle. If a particular angle called angle of polarization. Some light rays are reflected, some light rays are refracted. The refracted ray examined, it is a plane polarized light. So, This is actually called polarization by reflection. Anybody wants to get polarized light, you can take from reflected light. So this is IP, particular angle of incidence called angle of polarization. So this is called R. This is called reflected ray. This is also R. This is called 90 degree. Therefore, this R plus 90 plus 2 IP is equal to 180 degree. From which IP can be written as 90 minus IP or 90 minus R. Therefore, from Snell's law, mu is equal to sin IP by sin R or sin IP by sin 90 minus IP or sin IP by cos IP. That's equal to tan IP. Therefore, mu is equal to tan IP. This law is called a Brewster's law. The tangent of angle of polarization numerically equal to refractive index. Once we know IP, mu can be calculated. Once we know mu, IP can also be calculated. Like that we can call. This law actually called Brewster's law. But actually the polarization by reflection was given by the scientist Malus. So no explanation about Malus law in our state board, but in Southern board there is given. What is a Malus law? The Malus law clearly states that the intensity of polarization, that is I is equal to I naught cos square theta. So I is equal to I naught cos square theta is called Malus law, where I is called intensity of light, I naught is called the maximum intensity, theta is called the angle of rotation of the particular polarized. Once we know the theta, we can able to find out the intensity. So these are all given in the chart. That is the thing I have given the thing you have to understand it. So Malus law, I is equal to I naught cos square theta, polarization by reflection. Brewster's law, mu is equal to tan IP. Mu refractive index of the medium, IP, polarizing angle. What is called optical activity? The optical activity, we know certain crystals or its compounds in solution have the ability to rotate the plane of polarization of a plane polarized light. Sugar is an optical active. So and also in human body, how much the sugar level, diaptic level can be calculated by using this optical activity method. We are using some sample of your blood that should be rotated, centrifuge machine. So if it rotates, automatically it separates how much sugar it has. So the optical activity, sugar is an optical active substance. Photometry, photo means light, metry means measurement. The measurement of light is called photometry, measurements of concentrating visual radiation, that is light. Luminous intensity, we have to understand the definition. The luminous intensity I, light energy emitted by the source per unit time, per unit solid angle. So how much energy is emitted by the object per unit time, per unit solid angle in the particular direction. SI unit, candela. Candela is a unit for luminous intensity. Luminous flux. Flux always we are giving 5, electric flux, magnetic flux, like that. It is the amount of light energy emitted by a source per unit time, not the area. How much energy is emitted by the entire area emitted by the source by unit time. SI unit lumen. Lumen is the unit for luminous flux. Intensity candela. Then luminous flux phi is equal to 4 pi I. That is the relation between I and phi. Because I is the amount of energy emitted per unit area, where phi is the amount of right energy entire area. So that should be multiplied by area, automatically I get the value of phi. The unit lumen. Luminous efficiency. Luminous efficiency. It is the amount of luminous flux radiated by the source per unit of input power. Unit lumen per watts. Because per unit of power unit watts, we know the luminous flux unit is lumen. Therefore, lumen per W. That means amount of luminous flux, that is phi, radiated by the source per unit input power. This is the understanding given. For example, 40 watts bulb has efficiency. So we know your bulb, tungsten bulb. So kindly the tungsten bulb, anything printed on the bulb, 40 watts. So we are getting 220 volt commonly. Among the input power, the bulb consumes 40 watts. So it has 12 lumen per watt. That is called just now luminous efficiency. That is called efficiency. So the efficiency is 12 lumen per watt. 60 watt bulb has efficiency 14 lumen per watt. 500 watt bulb has efficiency 20 lumen per watt. 30 watts fluorescent tube light has 50 lumen per watt. That is the energy from the source, how much it is emitted per volt. That is called the thing I want to understand. This is an example. Illumination. ILLUMINATAY. Illumination. So we have seen something, what a bright it is, how it is illuminated, that brightness. It is the luminous flux falling per unit area, phi by A. So just like where B here, E, that is called luminous. Luminous can be calculated by luminous flux falling per unit area of the surface. Therefore, E is equal to phi by A. Also, intensity of illumination unit luminous lumen per meter square, lux. So if I take a normal line on the surface point P, illumination of a point P at a distance R from the source. Yes, this is a source. I want to find out the illumination. R from the source S of intensity I. Then E is equal to I cos theta by R square. This is a formula for finding illumination. So any surface, this is the distance of the source from the surface. Once we know E is equal to I cos theta by R square. Theta is the angle between the line SP and normal. So this is a normal, this is a line SP, this angle is called theta. If you have substitute this, we can able to find out the value of illumination, I cos theta by R square. What is the principle of photometry? The principle of photometry, you know, the ratio of intensities of two sources is equal to the ratio of intensities of two sources is equal to the ratio of the squares of their perpendicular distances from the screen. That is I1 by I2 is equal to R1 square by R2 square. I1 by I2 ratio of intensity. R1 we know square of their perpendicular distance from the green. R1 first source, R2 second source. Therefore, I1 by I2 is equal to R1 squared by R2 square. So these are why I am saying this is a photometry. That is also in our syllabus. In polarization, what is double refraction? The double refraction, we know, we take a point on a blackboard. If I place a black dot on the board, if it is our vicinity, we are having only one dot. If we are seeing through a crystal, instead of one dot, we are having two dots. If crystal is rotated, what happens? One dot is stationary, another dot is rotating over a stationary star. The stationary star is called ordinary ray. The stationary dot is called ordinary ray. The rotating dot is called extraordinary ray. So, the stationary dot we call as ordinary, the rotating dot is called extraordinary. So, even for a single incident light, we are having two refractions, hence they are called double refraction. That is also possible for the crystal. What is pila plate? Pila plate is an instrument used to produce polarized light. It is nothing but a polarizer in which the glass plates are mounted one over the other. That is called a pile, P-I-L-E, pile of plates. So in the pile of plate, if the light rays are incident, some light rays are refracted, some light rays are reflected. All the reflected light rays are examined, they are plane polarized. So this is nothing but a polarizer. The double refraction, the nickel prism also, you have some idea, nickel. The nickel prism is nothing but a transparent, is nothing but a prism which has angle 108 degree and 72. If two prisms called nickel prism are cut together and they again joined with a transparent cement called the candelabrum, they form one prism. That prism is called nickel prism. The angle of nickel prism 108 and 72 degree. If another light rays are incident, some light rays are refracted, some light rays are reflected. All the refracted light rays are like that, all the reflected light rays are plane polarized. Once you want to get a plane polarized light, we can get from the reflected. That is called polarization by reflection. What is monoaxial crystal? Any crystal which has only one optic axis is called monoaxial crystal. We know quartz, tourmaline, like that. All the crystal has only one optic axis. Some crystal has two optic axes called biaxial crystal. Topaz, selenite, like that. What is called optic axis? Optic axis is the axis in which the ordinary ray and the extraordinary ray travels with the same velocity. That is a place where ordinary and extraordinary ray travels with the same velocity is called optic axis. Then what is called the Polaroid? So we know polarides, H Polaroid, K Polaroid, like that. They are actually made of quinine thiosulfate. The Polaroid is used to produce polarized light as well as the analyze the light is polarized or not. Therefore, polarides is both the polarizer as well as the analyzer. That is also possible. Uses of polarides, everyone know. The Polaroid is very much useful to see the 3D picture. What is our 3D picture? Three-dimensional motion picture. Usually we are seeing the film in our theatre or anything that is called two-dimensional picture only. Two-dimensional picture means they affect only X and Y axis. If I move my hands, the hands in the X and Y axis alone. it won't come out of the screen. If it comes out of the screen, that is called 3D effect. To see the 3D effect, we are using this glass. This glass is called Polaroid glass. When we see the 3D picture, everyone experiences and the film is going on. If you are seeing around you, all the people are wearing a block spectacle. That spectacle is called Polaroid glass. So when you wear the Polaroid glass, we can enjoy the 3D effect. If we remove it, we cannot enjoy it. So that to see the third effect, that is depth effect, we have to use Polaroid glass. And also nowadays, to avoid glare, we are using sunglass. For sunglass also, if you are using Polaroid glass, it is better to avoid the glaring. That is called Polaroid. So any glass you are purchasing for sunglass, cooling glass, any brand, Mugijim, very costly one, 20,000 rupees, starts with 27,000 and maybe lakh. And also everyone, Ray-Ban, everyone aware of it, Ray-Ban. So Ray-Ban ordinary glass and also Polaroid glass. How can you distinguish? The glass itself, the letter P is printed. P meant for Polaroid. Because it filtered out all the ultraviolet rays. All harmful rays are filtered by Polaroid glass and only we are getting a useful light in our eye. So it can avoid glare. In railways and aeroplane, Polaroid glass are used as filters. So if you are using cooling glasses, what happens? Automatically we are getting a cooling effect. But unfortunately the intensity of light decreases because of the cooling effect of a particular glass. If we are using Polaroid glass, we are getting the same intensity level, but what happens? We are getting good cooling effect, no darkness. That is advantage of Polaroid glass. In all automobile headlights, everything you have to use Polaroid glass so that the glare may be avoided. When you pass on by motorcycle or car, if high beam light is on, what happens? Everything is confused for us. To avoid that, we are having only the Polaroid glass. And also the Polaroid glass are very much useful to see the older oil painting. Mohenjo-daro, Aranya, Ajanta, Ellora, we know everything, what a wonderful paintings. These paintings are made up of which material. So everything, the new concept can be identified by using the Polaroid glass. These are all the uses of Polaroid glasses. Now we can solve some problems in the wave optics. The problem wave optics also we have seen so far thoroughly about the wave optics. First we have to find the difference between geometrical optics and the wave optics. In the wave optics, we have studied about the wave nature. In a YDAC means that's double slit experiment. Each slit sends light of intensity I on the screen. Find the intensity at a point where the path difference is lambda by 4. So, once we know the path difference, we know the phase difference. I already discussed with the formula for phase difference, phi is equal to 2 pi by lambda into path difference. This is a general formula. Therefore, in our problem, 2 pi by lambda into lambda by 4. Lambda getting cancelled. Therefore, answer pi by 2. This is the phase difference. The resultant intensity, the question is asked. I already given in the discussion. The resultant intensity is 4i cos squared pi by 2. So here 4i cos squared phi value pi by 2, therefore pi by that's equal to 4I by 2. Because cos 60 square of value 4I, that's equal to 2I. So, in the Young's double slit experiment, each slit sends light of intensity I in the screen. Find the intensity at a point where the path difference is lambda by 4. If the path difference is lambda by 4, automatically intensity of light twice the incident light. This is our first type of law. In the Young's double slit experiment, two narrow slits 0.8 millimeter apart are illuminated by the same source of wavelength 5893 angstrom. How far apart are the adjacent bright band in the interference pattern observed on a screen 2 meter? 2 meter away means we are getting the value of capital D, and 0.8 millimeter we are giving the value of small d. We know the path difference, beta formula, capital D by small d into lambda. Everyone aware of it, capital D by small d into lambda. That is capital D value we are getting 2 meter away into wavelength 5893 angstrom means 10 power minus 10 meters. 1 angstrom 10 power minus 10 meters. Divided by small d value given as 0.8 millimeter, therefore 10 power minus 3 meter. On simplification, 1.47 millimeter again. So this is a bandwidth. In the Young's double slit experiment, two narrow slits 0.8 millimeter apart are illuminated by the same source of wavelength. How far apart are the adjacent bright band? What is the thing you have to understand it? What is the how far apart the to adjacent the bright band or dark band means? The distance between two consecutive bright or dark band is called bandwidth. The question is asked to find the bandwidth. Problem number 3. In Young's double slit experiment, the central fringe of the interference pattern produced by a light of wavelength 6000 angstrom A is shifted to the position of the fifth bright fringe. When a thin transparent sheet of refractive index 1.5 is introduced in front of one of the slits, find the thickness of the sheet. So this is I already given in the discussion. As far as the path of the light, if any one of the slit is closed, what happened to the frame? If any one of the slit is closed, we are not getting any interference pattern, uniform illumination taking place on the screen. But what about here? Here we are introducing a transparent glass plate of thickness T. Then what happened? Then there is a shift of fringe also, we know. So here the shift formula are given like that, capital D by small d into mu minus 1 into T. Here it is towards the fifth bright band, therefore d by d into lambda is equal to d by d into mu minus 1 into T. This d by d getting cancels, that is the advantage of this problem. T is equal to 5 lambda by mu minus 1. That is 5 into 6 into 10 power minus 7, 1.5 minus 5. Therefore 5 into 6 into 10 power minus 7 by 0.5. This 0.5 nothing but half, therefore 10 into 6, therefore 60 into 10 power minus 7 meter is the thickness. Very simple problem. This 6 into 60 into 10 power minus 7 or meter. It is converted to centimeter, whatever. This is the answer we have to be noted. How can we understand everything? This is also, it's not a direct problem, this is also repeated a problem in entrance. If the transparent glass plate of thickness T introduced, what happened? Then there is a shift of fringe. So kindly go through the theory we have taught in the slide. If you are introducing the thickness, of the slit, automatically there is a shift towards right form. This is also very important for our discussion. Next problem. The angular width of central maximum, the height of wavelength 6328 angstrom is incident on a slit having a width 0.2 millimeter. The distance of the screen from the slit is 0.9 meter. Distance of the screen means that value capital D. Calculate the angular width. We know the angular width theta is equal to lambda by A, full angular width 2 lambda by A. That is 2 into lambda value 6328 into 10 power minus 10 meters divided by width 2 into 10 power minus or 0.2 into 10 power minus 3. On simplification, it is because it should be converted into radian, it is 180 by 5. That's equal to 0.36 degree. This is the angular width. So the width may be converted into radian, that is 180 by 5. Pi value everyone knows. So this is the one method for finding the angular width. Half angular width lambda by A, full width lambda by 2 lambda by A. The distance of the screen from the slit. Calculate the angular width of central maximum. So height of lambda. That is the thing how to understand. A 100 watt isotropic bulb has luminous intensity of 125 candela. Calculate the luminous efficiency of the bulb. Just now I have given the formula for luminous efficiency is always equal to luminous flux, that is 5 divided by input power. What is the power? Input. So that is W. So luminous 4 pi into that intensity 125 divided by 100 watts are given on simplification. Simply 5 pi lumen per watt. This is a direct problem in the intensity of light. That luminous flux divided by input power. Therefore, lumen per watt. So that you have to keep your mind about the definition: luminous flux, luminous intensity. What is luminous efficiency? So how to. Now problem is 6. A slit is illuminated by light of wavelength 6500 angstrom. What would be the width of the slit so that the first minimum falls at the angle of diffraction 30 degree? So here the question is asked to find out the slit width. This is a right problem. We know sin theta equal to lambda by A sin theta is equal to n lambda. For first order, n is equal to 1, sin theta is equal to lambda by A, or A is equal to lambda by sin theta. So lambda 6500 into 10 power minus 10 meter into, that is lambda, divided by sin. What would be the width of the slit so that 30 degree? Sin 30 we know half. This goes there, that is 1.3 into 10 power minus 6 meter. Because sin 30 half value, so half into 6.5 into 10 power minus 7 or minus 6. So that is equal to 13 into 10 power minus 6. The polarizing angle for a medium is 60 degree. IP is given. What is the critical angle for this medium? The critical angle is asked. These are two problems here. We know Brewster's law, mu is equal to tan IP, that is equal to tan 60. We know tan 60 value root 3. Mu is equal to root 3. We know mu is equal to 1 by sin C critical angle. Therefore, sin C is equal to 1 by mu, that is equal to 1 by root 3. Therefore, C is equal to sin inverse of 1 by root. Simply you can put directly. So these are all the problems in wave arcing. And also sometimes the problem is asked sometime in the basic concept oriented, how can you calculate? Like that one problem recently asked. So if you are using sodium as a source, sodium, we know sodium has 5893 angstrom as a source. The number of fringes observed, observed 62. The word given in the problem, in the same field of view, instead of sodium, the source is replaced by green light. That means white light using with the green filter. 5461 angstrom. What happened to the fringe? So this is a concept oriented. In the concept oriented, when the wavelength changes, what is the number of fringes? Is there any relation? We know generally the number of fringes inversely proportional to bandwidth, or n into beta is equal to constant. Everyone aware of it. If there is a thick band, the number will be less. If there is a thin band, it occupies large numbers. Therefore, n1 beta 1 must be equal to n2 beta. But n1 beta 1 we know d by d into lambda 1 is equal to n2 into d by d into lambda. Why is d by d is same? That is a concept here. This d by d is same because in the same field of view. We are not altering the distance between the source and the screen or distance between the screen. They are same. Therefore, from this I have a new concept, n1 lambda 1 is equal to n2 lambda 2. If this condition is satisfied, n is inversely proportional to wavelength. That is also true. That is number of fringes inversely proportional to wavelength. So here the question, kindly go through the question. The first question 5893. The second question 5461. So the wavelength decreases. As per this concept, if the wavelength decreases, number of fringes should be increases. Therefore, answer should be more than 62. Otherwise, we can put here also n2 is nothing but n1 lambda 1 by lambda 2, n1 62, lambda 1 5893 angstrom divided by 5461 angstrom. Everything cancels, nearly 67. So the answer is 67 fringes are observed. So like that the problem may be asked. So you have to keep your mind. So another type of problem is also asked in sometimes in the grating is concerned. The number of lines per grating may be 40,000 lines are drawn. Therefore the capital N value is given. Calculate the maximum resolving power. Here also grating element value given. Grating element is 12.5 into 10 power minus 7 meters. So the grating has its element 12.5 into 10 power minus 7 meter and has the line 40,000 lines. Calculate the maximum resolving power. The problem is calculate maximum resolving power of grating. Resolving power, for which the wavelength of light used is 5000 angstrom. So in this case, I already given the formula for small n into capital N or lambda by d lambda. In this problem, lambda is given, no d lambda. And the capital N value given, no small n. How can you calculate? So this concept is, we know for grading, I have given in the chart itself, a plus b sin theta is equal to n lambda. For maximum resolving power, sin theta value 1, therefore n is equal to simply a plus b by lambda, that is 12.5 into 10 power minus 7 by 5 into 10 power minus 7. So I got the value 2.5 as small n. Capital N value 40,000. So we are getting the 4 answer, that is 40,000. B answer 80,000. C answer 1 lakh. D answer 1,20,000. Usually as per the problem, everyone tick the value small n to capital N is 1 lakh. But unfortunately, you should not take like that. What is the concept here? See what n is an order. What is called n? N is an order. If the violet to red, there is a first order. If move the telescope in the same direction, we are getting additional order. Again violet comes. If it goes to red, then only the 2 orders are completed. So as far as here, the completing order 2.5 means only 2. So order should be completed or should be taken. That is the concept of this NEET class. N is an complete order. You should not round off 3 or 2. So here 2 must be there. Even 2.9 comes, you have to take as 2. Therefore 2 into 40,000. The correct answer is 80,000. In some book they are putting 1 lakh. That is not correct. So these are all the information I have given in the chapters as far as the wave optics is concerned. Kindly go through the wave optics thoroughly, and it is very useful for your final examination. These are the problems. Additionally, I have given for your concept oriented. So remaining the next chapter, we will see in the next class. Thank you.